maybe for later dates. And then we have our fall speed here, which has not been calculated because we haven't received that data. Because it's so small, I actually went and got the gravitational field at this longitude and latitude, so, or at least in close to Virginia. So I'm saying that it's 9.798842. And then the density of oil, it's 886. So it's just mineral oil. Okay, it's a laxative. It's what people drink in order to go to the restroom. All right, so we're using mineral oil. And then we have some calculations over here. These are the calculations that are going to go into the equation to actually find the radius. So all of those numbers before, we use all of these numbers to perform these calculations. B divided by 2p. B divided by 2p squared. 9 times eta times the fall velocity. 2 times gravity times the density of oil. And then once we have these things, we put them together in the radius formula here. So you'll see that we have a radius formula. If I just went through these, you'll see it's a formula for each one of these. All of the other ones are numbers except for this reference here, this fall speed. It's referring back to the average velocities. After we do that, we go to mass, and we can calculate mass because mass is just equal to the density times the volume. The density of the oil times the volume. And the way we calculate the volume is 4/3 pi r cubed. So if I went here, you'll see I have 4/3 pi, and then C represents radius, r cubed times b. Stuff that you could easily do. It's not difficult to put these formulas in at all. I used to have the class do them, so I know you can do it. And so we're going to have our mass referenced back to the previous page. We have our fall velocity, our rise velocity. Gravity is still the same. You know what? I probably should have referenced this because I did change it. But don't you worry about reference. I'll change it in the document that you pull down. So let me just say equals to, and I'll go back to that page. So if you're going to have something that's going to be repeated throughout, just reference the 1, and then when you change the 1, it'll go throughout the entire page. So fall velocity, rise velocity. We have our potential difference. This is just voltage. So we have 495 volts. And then we have our plate separation here. It's 0.076. So it's kind of like a capacitor. We'll talk about capacitors in a little bit, but it's a capacitor. So you just have 2 plates, and you generate an electric field between that capacitor, and you cause this oil droplet to rise and fall, okay? And then after the plate separation, which is just a number, we have our electric intensity, and it's just the potential difference, okay? You'll see F3 divided by the plate separation. So this is our electric, it's volts per meter, okay? And then we have our charge calculated. So the charge will be calculated with these values that are being generated. We have our, and so let me just make this point. If you have a large equation or something that's it's just crazy looking, if you can get over that hill or over that mountain that it's crazy looking, and then break it down into small parts, put it into Microsoft Excel, it's not a thing. There's not an equation that you can't solve, pretty much. Not at our level, you know what I'm saying? I think at anybody's level, to be honest with you, but whatever. Okay, that's my, let me get off that soapbox. So we have division by 0, that's just our calculated charge. The accepted value for charge is 1.60 e to the negative 19. And the number of charges is just going to be calculated by us taking this value and dividing it into what we have here. And so I only have this in increments of 1, 2. I'm only taking integers. So everything else is an error. Okay. So if we come out with something like 100, like 2 e negative 19th, we'll divide that in, and we're going to get some whole number plus a fraction. It's just going to be 1. Every charge or electrons come in discrete quantities, and we know those discrete quantities, and it's 1.60 e negative 19. All right.